covering the topic of functions in IBDP, and we'll be looking at a bunch of past paper questions for the same. So let's just begin. So the first question we're looking at is from an AAHL paper 1. This is based on quadratics, you can see. So the function is given in the factorized form, and they are asking us to convert it to the vertex form. One way would be to expand it and then convert. Instead, we're going to be smart about it. We know that the vertex would always lie between the two roots. So I can just get the x-coordinate of vertex by taking the average of the two roots. So the two roots are -1 and -3. To get the vertex, that's the h value, the x-coordinate, we just take the average, -1, -3 over 2, which gets us -4 over 2, that is a -2. That's your x-coordinate. To get the y-coordinate, we could simply just plug that in into the function. So we'll find f of -2. That's 5 times -2 plus 1 times -2 plus 3, which gets us 5 times -1 times 1, that's -5. So our vertex is -2, comma -5. So the answer for the A part, I'll just plug in h as -2 and k as -5. A value already remains as 5. So f of x becomes 5 times x plus 2 squared minus 5. That would be the A part. B part is asking us to sketch the graph, and since it's AAHL paper 1, we don't have the calculator. So we'll be marking all the roots and vertex on the xy plane. So we have -2, -5 as the root. Then we have negative, my bad, -1 and -3. Sorry, -1. -3 at -2 comma -5 we have the vertex, so -5 would be somewhere here, and then we just join these, and we also have the y-intercept, which would be 15. If you put x as 0, you'll get 15, so that's where the graph would cut the y-axis. So that's the graph. They also asked us to mark the vertex, so we'll mark -2 comma -5. The C part is asking us to solve the inequality f of x less than or equal to 40. So I'm going to go on to the next page for more space. Less than or equal to 40. So we can use the vertex form for this. That would be the easiest. So I'm going to write down the f of x function in the vertex form and put it less than or equal to 40. From here, I can take the -5 to the right. So 5 times x plus 2 squared is less than equal to 45. Dividing by 5, x plus 2 squared is less than or equal to 9. Now, since it's a square inequality, x plus 2 would now lie between -3 and 3 when we take the square root. Then we would subtract 2 from both sides. So it gets us x is less than equal -5, greater than equal -5, and less than equal 1. So it's between -5 and 1. That would be the answer for the C part. Going back up, the next part is giving us another function g of x, that's ln x, and we have to write an expression for f o g of x. So g of x is ln x, and we have to find f of g of x. It's the composite function, so that means I need f of ln x. The function f was our original quadratic, so we'll have to simply put ln x in place of x. So you can use either form here, the factorized or the vertex. So if I use the vertex form, because it's right in front of me, 5 times ln x plus 2 squared minus 5. So that's 5 times, I'll open the square bracket, so that's ln x squared plus 4 ln x plus 4 minus 5. That is 5 times ln x squared plus 20 times ln x. Then that'll be plus 20 minus 5, which becomes 15. So that's our expression for the composite function. Next, they are asking to solve the inequality when our composite function is less than equals 40. So this was the first part. Now we have to solve for the composite being less than equal to 40, which means 5 times ln x squared plus 20 ln x plus 15 is less than equal 40, which means I can take the 40 to the left. So 5 times ln x squared plus 20 times of ln x, negative 25 is less than equal to 0. All right. Now, if you see, this is a quadratic in disguise. You just have to replace the ln x with a different variable for the time being. So I'll put y as ln x. So that gets us 5y squared plus 20y minus 25 is less than equal to 0. We can divide by 5 throughout. So that's y squared plus 4y minus 5 is less than equal to 0. So now we have a quadratic being less than or equal to 0. So all we have to do here is solve for y. We'll have to factorize this out. So by simply factorizing, I'm going to write it here. We will get y plus 5 and y minus 1 is less than equal to 0. So whenever I want a quadratic to be negative and it's a concave up quadratic, then I would want to stay between the two roots. So I have to stay between negative 5 and 1. Y was nothing but ln x, so that means ln x has to stay between negative 5 and 1, which means x has to stay between e to the negative 5 and e to the 1. So this would be the interval for x. That's the answer. All right, I think we have one more part left here. It's asking for domain of g of f. Okay. So initially we were working with f of g. Now we have to find the domain of g of f. So we'll have to first find that function out. All right. So g of f of x, that's going to be ln of f of x. So if I have log of anything, we know that I cannot put negative values. Sorry. Okay. Somebody's asking if we'll be doing AISL, and yes, we do have some questions on AISL. We have two questions, paper one and paper two in AISL. It's a little ahead. Okay. Um, so whenever we have ln of f of x, we want to make sure that the function inside is always positive. So f of x is greater equal 0 is what we want, not equal, just greater. We can't even put 0 inside log, right? So we want, I'll keep the factorized form, 5 times of x plus 1, x plus 3 is greater than 0. So x plus 1 times of x plus 3 is greater than 0. So if a quadratic is concave up and I want it to be positive, its roots are 1 and 3. That means I want it to stay in here and in here. That means I would want it to be less than negative 1 or greater than 3. And that would be the domain of the function g of f of x. All right, that was the first question. We'll move ahead to the next one. This one is from AASL paper 1. So you can see they've given a diagram for this function, y equals to negative 1, negative root of x plus 3. They've also given the domain for the same. And then the question is to describe a sequence of transformation that will transform the graph of root x to this graph. So we have to go from root x, make some transformation, and get to this graph. So first off, we would want the plus 3 inside the root. So whenever I'm adding something to x, I'm moving to the left. And then we also have the negative sign here in the front, which will make a reflection in the x-axis. And then we also have a vertical translation. So we could go about with a reflection first. So a reflection in the x-axis, that's because of the minus sign in front. So that would take a root x to minus root x. Then a horizontal translation, 3 units to the left. So that would take our negative root x to negative root x plus 3. And finally, a vertical translation, 1 unit down. So that would take our negative root x plus 3 to negative 1, negative root x plus 3. So these three transformations will get us from root x to negative 1, negative root x plus 3. Now, next, they want the range of the function. So remember, root functions can never be negative. So whatever's inside root is always positive. So this thing, root of x plus 3, would be always a positive number, greater or equal to 0. Which means the negative of this would always be less than equal to 0. That would always be negative. And then if on both sides I just subtract 1, so minus 1, so that would mean that this guy entirely is less than equal to 1. So our f of x is always less than equal to negative 1. This is our range. Next, we have to find an expression for f inverse of x stating its domain. So to find the inverse of any function, we first flip x and y. We write x in place of y, y in place of x, and then make y the subject. So we have y equals minus 1 minus root x plus 3. I will first flip x and y, which gets me x equals negative 1 negative root y plus 3. And now my goal is to make y the subject. So I'll take the root term to the left. So that gets me root over y plus 3 equals negative 1 negative x. And then I will square on both sides. So y plus 3 would be equal to negative 1 negative x squared. So y plus 3 equals 1 plus 2x plus x squared. So y equals, I can take the 3 to the right side and rearrange a bit. So x squared plus 2x minus 2. So this is our f inverse of x. X squared plus 2x minus 2. Right, that was the C part. Oh, they're also asking to state its domain. So for a quadratic, the domain is always all real numbers, but we also need to make sure that the range of f matches the domain of f inverse. So all we need to state is that the domain is x less than equal to minus 1, because it has to be the range of the f function. That's how it goes for inverse functions. Yes, we can have 0 on the under root. Right. Then the next part is to find the coordinates of the points where the graphs of y equals f of x and y equals f inverse x intersect. So we have to find the points where these two graphs are intersecting. So we basically have to solve for fx and f inverse x being equal to each other, but that would be a really long process, a quadratic and a square root function. We also know a fact that they will meet on the y equals to x line. So I can just simply either equate f of x to x or f inverse x to x. So I'm going to get rid of this. And we're going to equate f of x to x in order to get the intersection of f and f inverse, because they meet on the line y equals to x. So I'll just simply do negative x, negative 1, negative square root x plus 3 equals x. I would square the both sides. So that's 1 plus x plus 3 plus 2 root x plus 3 equals x squared. I'll have to, Okay, so root of x plus 3 can now be substituted. So from here, I had -1 minus x equals root of x plus 3. So I can replace that over here. So 1 plus x plus 3 plus 2 times, I'm putting this instead, -1 minus x equals x squared. So 1 plus x plus 3 minus 2x is x squared. So 2 minus x is x squared plus x minus 2 is 0. And then this can be solved with the quadratic, and I'm just going to write the answer here. You can use the quadratic formula and give it. So your answer will come out to be -2 and 1. You can also factorize and solve. So that's straightforward. The key here was that do not equate f and f inverse, equate f and f of x equal to x for ease. And then when I had this root, I substituted it with this value to make it easy into a quadratic. Okay. Next, we have a question from the AASL paper 2. So now you can use the GDC. We have f of x equals, this is x minus 8. Can't see that. This is x minus 8. And we have to find h, the function, which is a composition of f1, f, and g. So that would be f of g of x. We have the function g, which is x to the power 4 minus 3. So we have to find f of that, which means wherever there's x, I have to put x to the 4 minus 3. And then we have a minus 8. So that's pretty direct, x to the power 4 minus 11. That's our h of x function. Then they're saying that let C be a point on the graph of H. The tangent to the graph of H at C is parallel to the graph of F. We have to find the x coordinate of C. So this goes a little bit into the calculus part. So they're saying that the tangent of H at C is parallel to the graph of F. So if I want to find a tangent, that means I have to take the derivative. So I'll have to find the H dash of x, which will come out to be 4x to the power of 3. And they're saying that it's parallel to the graph of f. That means the slope should be same as that of f. Now f is a line x minus 8. Slope of this line, if I compare it with mx plus c, the slope of this line is just 1. That means we want the derivative to be equal to 1, which gets us x cubed equals 1 over 4, which gives us x as cube root of 1 over 4. And they want the exact answer here, so you'll use your GDC to get the decimal point, which will turn out to be about to three significant figures 0.63. So that would be the answer. Moving on, we have an AAHL paper 2 question. So they've given us a function, it's a log function. We have to draw a set of axes showing x and y values between -3 and 3 and find the coordinates of the point of inflection on the graph. So first thing, to find points of inflection, we have to find the roots of double derivative. So this works out in your GDC very easily. What you'll do is you'll put the function f, and then you would graph it. And in the graph, in the graphing tool, you can also graph the derivative and double derivative without even finding them. So you'll directly get the graph of the derivative and the double derivative by just putting y equals to, if let's say you put it as f1, depending on your calculator, you can do df1 by dx. And when you put that, that would probably be f2. Your calculator will directly graph the derivative. You don't have to find the derivative to do that. So once you have that, you'll also find the derivative, the double derivatives graph. You'll also graph that. So what you'll do is you'll make another graph for df2 by dx. So the derivative of the derivative. And once you have that, all you have to do is locate its x-intercept. That's where the double derivative would be 0. And once you do that, you'll find the x value to be 0.899. And to get the y value, what you'll do is you'll put x in here in this function in your GDC and get the y value. which will come out to be negative 0.375. So this is all your GDC. You just need to know what to do. That the double derivative has to be 0 for inflection point, and there you have it. Next, they want us to sketch the graph, clearly showing any axis intercepts and giving the equations of any asymptotes. So I'm going to go on to the next page so that I have space. Here. Okay. So again, it's simple to graph. You just have to put it in your GDC. I'm just going to show how your graph would look like and how you should be, making the graph from your GDC in your paper. So you'll see the graph of F would somehow look like this. This is F. It has asymptote over here at 3, x equals to 3, a vertical asymptote. X equals to 0, that means the y-axis is also an asymptote. And you'll have to mark the x-intercept here. That would be 0.607 comma 0. And that would be your graph for f of x. I think they're asking for the graph of f inverse x as well. So in the same set, we can draw that. So you don't need the GDC for making the f inverse graph. All you have to do is reflect it in the y equals to x line. So in the y equals to x line, if I reflect the graph, I would get something, it would connect here. The intercept would now be over here, and the asymptote would now be y equals to 3 and y equals to 0. It will go like this. And this point would be 0, comma 0.607. And that would be your graph for f and f inverse. And then they want us to solve the inequality f of x greater than f inverse of x. So we have to find the places where the graph of f is above the graph of f inverse. So if you look carefully in the graph, there would be a region. So basically, before x equals to 0, we don't even have the graph of f. So we can't look at that. We can look at this region where your yellow graph is above the blue graph. That means f is above f inverse graph. So from 0 till this point, we can see that the blue graph is below the yellow graph. So that's when our fx is greater than f inverse x. After that, it becomes smaller. So in your GDC, what you'll do is you'll find this intersection point of your function with the y equals to x line. And that will come out to be, the x coordinate will come out to be 0.372. So your simple answer for f being greater than f inverse is that x is between 0 to 0.372. Make sure you're always rounding to 3 significant figures. All right. So this question was GDC heavy. All you had to do was put things in the calculator and you get the answer. You just need to know what you're supposed to do. Okay. Next, we have AISL paper 1. So this question is also based on quadratics. They've given a quadratic function and they've given the vertex to us. They say that the equation fx equals to k has two solutions. One of these solutions is x equals to 2. So x equals to 2 must be somewhere here, or it could be somewhere here. We don't know that. But that means there's a horizontal line which intersects at x equals to 2. They're asking us to write the other solution of f of x equals to k. So here, we don't need to do any calculation. It's all about symmetry. So for example, if this is the line, and here is the point 2 where the line meets it. So this is another point where it meets, and this is what we need to find. Now, we don't need any equation for that. The reason is a parabola is always symmetric. So the vertex is going to be in the middle of these 2 points always. It's not only in the middle of the 2 roots, it's always in the middle of any 2 points which have the same y coordinates. So let me call this point as x. So that means x plus 2 over 2, that means average of x and 2 should get me the x coordinate of the vertex, which is negative 2. So x plus 2 is negative 4 and x is negative 6. So that means this distance and this distance has to be the same. So the other root is -6. All right. Next, we have to complete the table below, placing a tick to show whether the known parameters are positive, 0, or negative. And the row for C has been completed for an example. I think it's not completed in here, but just for the, oh, it is, it is. We can see that the C value is positive. That's already given. Okay, so let's see. We have a concave down parabola, which clearly tells us that A is negative, right? But we have to figure out what about B. So they've already given us that the C value is positive, and it makes sense. The y-intercept is positive. So we have ax squared plus bx plus c, where we figured that A is definitely negative, C is given to be positive. For B, we can think of the vertex. So we know the formula for the x coordinate of vertex is minus B over 2A. And that is given to us as -2. We know already that A is negative. If A is negative, that negative sign goes away with this negative sign. But we still need another negative sign. So B has to compensate for that. So that means B itself has to be -2. And that means A and B both are negative. Next, they want the values of x for which f is decreasing. So this is a parabola. On the left of the vertex, it's increasing. On the right, it's decreasing. That means we need this region. That means simple. We just need to be above the x value of the vertex, which means we want x to be greater than -2. In this case, if you write greater than equal to -2, that's also correct. Both of these answers will be marked correct. All right. Next, we have an AISL paper 2 question. This is a Ferris wheel question, the famous Ferris wheel question. Okay, so I'm just going to give you guys a minute to look over it because it's a long question to read. Okay, so we have a Ferris wheel. Um, a person would start riding it from the bottom, of course, and they've given us the diameter of the Ferris wheel, 61.8. It's at situated at a platform, so it's 2.7 meters above the ground level. They've also given us the revolutions per minute. It's making 1.5 revolutions in a minute, and they're saying it can be modeled by this function. It's a negative cosine wave. Okay. Then we have to calculate the value of, okay, so it's a little, uh, yeah, we have to calculate the value of A, B, and D. So let's go back up and do that. A, B, and D. Those are these values. So this is all the information we need for that. So A is, of course, the amplitude. So amplitude is going to be, if you use the formula says it's maximum minus minimum over 2. So the maximum height that our Ferris wheel can go to is 64.5. These two added together, 61.8 plus 2.7, that's the maximum height the Ferris wheel can get to, minus the minimum height it can get to, which is just 2.7 over 2. So your A value just comes out to be 30.9 meters. That's straightforward. B is related to the period of the revolution. So first let's find the period. So we know it's 1.5 revolutions per minute. Period is about in how much time are you completing one revolution. So if I have 1.5 revolutions in a minute, that means I would have um, so in 1.5 revolutions in like 60 seconds is what we have. So if I want one revolution, that would be 60 over 1.5 seconds, which would be uh, 63 over 2. So that's 40 seconds. So in 40 seconds, you would complete one revolution. So if I want the value of B, that's just going to be 360 divided by the period. which is, so time t here is in seconds, so we can keep it in seconds. So 360 over 40, which is 9. So our b value is 9. Then we have to find the d value. D is the central axis. So that's maximum plus minimum by 2. So the same values we used for A, we're just adding instead. So 64.5 plus 2.7 over 2, which is simply going to be 33.6 meters. That's the value of D. So basically, we just found out all the parameters of a cosine wave based on all the information that was given to us. The period thing could be tricky, but remember, period is always about in how much time are you completing one wave, right? So one wave in here refers to one revolution. Okay, moving on. They're saying that the ride on the Ferris wheel lasts for 12 minutes in total. All right, what's the next question? Calculate the number of revolutions of the Ferris wheel per ride. So they said one a ride would last for 12 minutes, right? In 1 minute, we were having 1.5 revolutions. So in 12 minutes, how many revolutions would be there? That would simply be 12 times 1.5, which is 18 revolutions. That was straightforward. That's all that the B part is asking for. The number of revolutions for one ride. Um, okay. Then for exactly one ride on the Ferris wheel, suggest an appropriate domain for h of t and an appropriate range for h of t. So for one ride, what should be the domain? So basically, one ride is happening for 18 revolutions. Um, that is 12 minutes. So if it's happening for 12 minutes, I would want the t value to lie between 0 and 720. That would be 360 times 2. And the appropriate range would, of course, be from 2.7 to the maximum and minimum that we already had, 64.5. Okay, what's the next information? Okay, so the big text is a 16.7-meter tall cowboy statue that stands on the horizontal ground next to the Ferris wheel. Okay, we have a statue. Um, and there is a plan to relocate this. Okay, that's going to be for the next part. So let's do the D part. By considering the graph of h, determine the length of time during one revolution of the Ferris wheel for which the chair is higher than the cowboy statue. Okay, so we'll graph h of t. You'll graph h of t in your calculator, which would be h of x if you want, and you'll graph the height. What was the height given? 16.7. So we'll graph y equals 16.7. That would be a horizontal line. So you have your cosine wave and you have a horizontal line 16 at 16.7. That's what you'll get in your calculator. And once you do that, you'll find the two intersection points, which will come out to be 6.315 something and 33.684 something. So to find the interval, the length of time for one revolution for which it's higher, that means it's in this interval, I just have to subtract these two values. That would get me the length of time, which will come out to be 27.4. All right. So next, there's a plan to relocate the Texas Star Ferris wheel onto a taller platform, which will increase the maximum height of the Ferris wheel to 65.2. This will change the value of one parameter, A, B, or D, found in part A. Okay, so which parameter would now change? So look, whenever we talk about amplitude, it's about um, how high you would be going from the middle line or how low would you going from the middle line. So we're not changing the diameter of the Ferris wheel, which means that A value doesn't get affected. The number of revolutions are also not changing, so B also doesn't get affected. So the only parameter that changes would be D. So that's the only parameter that changes, d. Find the new value of this parameter. Straightforward. Um, we now have new platform height, which is 3.4. So the minimum value is now 3.4. And the maximum value is the maximum height that it can reach, which they gave us to as 65.2. 65.2. And then we would use this 65.2 plus 3.4 over 2, which will get us 34.3. How I found the minimum value of the platform, that means the place where they place the Ferris wheel, that's basically the total height that was given 65.2. I would subtract that from the 61.8 and 2.7. That means I removed the old platform and the height of the Ferris wheel from the maximum height now, and that would get you 0.7. That means the platform got increased by 0.7. Initially it was 2.7. Now if I add 0.7 to it, it gets 3.4. So that's the minimum there. All right, so moving on. We have a question from AIHL paper 2 about a wind turbine. So again, I'm going to give you a minute to read this. Okay, so we've been given dimensions of the wind turbine. We've given that the point B is at 90 meters and the length of the blades is 40, and C is at H height above the ground. And the blades are rotating, of course. We have to find the maximum value of H and the minimum value of H. Okay, so maximum, that would be 90 plus 40. When the blade comes at the top, the highest that you can go is 90 plus 40, which is 130. And the minimum would simply be 90 minus 40, because when the blade comes over here, this is 40. So the lowest position that it's at from the ground is 90 minus 40. So 90 plus 40 and 90 minus 40, which is 130 and 50 meters. Right. Then the B first part, find the time in seconds it takes for the blade to make one complete rotation under these conditions. So this is the condition given to us. The blades of the turbine complete 12 rotations per minute under normal conditions. So 12 rotations in 1 minute. So that means 12 rotations in 60 seconds. So one rotation would be in 16 over 12 seconds. That is how much? 5 seconds. So we have in 5 seconds it will complete one single rotation. Calculate the angle in degrees that the blade turns through in 1 second. So total angle that the blade has to travel through in one rotation is 360 degrees, and it's doing it all in 5 seconds. So all I have to do is do 360 divided by 5, which is 72 degrees. So it turns 72 degrees in 1 second. We have to write down the amplitude of the function. So amplitude is simply 40. You can see that's what's multiplied to the cosine function. Let's see. Then find the period of the function. So amplitude was 40. The negative sign doesn't count for the amplitude. That's only because the wave goes down first, not up. Then you have to find the period of the function. So that's just going to be 360 over the b value. That is 360 over 72, which will come out to be 5. So the period is 5. Sketch the function, clearly labeling the coordinates of the maximum and minimum. So we have a negative cosine wave. The minimum is 50, so it begins at 50, goes all the way till 130. This point right here, the maximum point would be at 2.5, half of the period, 2.5 comma 130, and this would be at 5, so 5 comma 50. That's our cosine wave. You can also use the GDC to sketch that. You can just put this in the calculator. Next, we have more questions. Find the height of C above the ground when t is equal to 2. So all you have to do is plug 2 in place of t in the h of t function. So that would be 90 minus 40 cosine 2 times of 72. And then you just plug this into the calculator and you would get the answer as 122 meters. Find the time in seconds that point C is above a height of 100 meters during each complete rotation. So now this also needs your calculator. You will make the graph and you'll draw the line y equals to 100, the horizontal line. And then you'll find the two intersection points here, this one and this one. That will turn out to be 3.55 and 1. Writing the opposite, 3.55 here and 1.45. So these will be the points of intersection on the graph. And then you'll just subtract these two to get the interval of time for which your graph is above the line y equals to 100. We want it above that. So when you subtract, you'll get the answer as 2.1 seconds, 2.10, so that it's rounded to 3 significant figures. Okay, the wind speed increases and the blades rotate faster, but still at a constant rate. Given that the point C is now higher than 110 meters for 1 second during each complete rotation, find the time for one complete rotation. So this is a bit tricky. So now they have not given us the period or the time of rotation or anything, but they're giving us information about point C being higher than 110 meters for 1 second. So that means if I draw the graph and if I draw the line y equals to 110, then this interval is that of 1 second. So what I'll do now is, now of course the period is affected, right? So the period changes. So my function is 90 minus 40 cos bt, some b value I don't know because the period is different now. So what I'll do is I'll first find when does it become 110? How does it become 110? So if I do that, I have negative 20 equals 40 cos bt. So cosine bt is negative 0.5. Now cosine is negative 0.5 in the second and third quadrant. So that would be at 120 degrees and 240 degrees. So now the thing is, these are the 2 points where it's becoming 110. That means these intersection points are 120 over b and 240 over b. And they said that this interval is 1 second. So that means 240 over b minus 120 over b is just 1. The denominators are the same, so I can subtract. 120 over b is 1, so b is just 120. So the period is now 120. And that's what they were asking for, time for one complete rotation. That is 120 seconds. That's what the period means. That would be the answer. Next, we have a question from AIHL paper 1. Okay, so they've given us a graph already. They've given that the graph passes through certain points. And they have given us, so this is minus 2, comma 6 and 0, comma 1. Yeah. And they've also given us the equation that there's another function g, which is a transformation of f. We have to find g of 0. So g of 0 is simply when I'll plug x as 0 in here, so 0 minus 2 plus 4, which is 2 times f of negative 2 plus 4. Um, so now basically all I need is the function's value at negative 2. So at negative 2, the value of the function is 6. So we have 2 times 6 plus 4, which is 12 plus 4, which is just 16. So that's the value. On the same set of axes, draw the graph of G. Okay, so first let's analyze what kind of transformation it is. So if we look closely, the transformation first takes it 2 units to the right, it doubles it, so there's a vertical stretch, and then it's moving upwards by 4 units. So let's see. At 0, it was 16, so it should be over here. The horizontal asymptote for this graph was at 0. Now it has moved 4 units up. So the horizontal asymptote should be at 4. And there's a stretch, so it should look more stretched out. So the graph would simply go like that. And that's all you have to do for it. The graph is stretched by a factor of 2. Y-intercept is changed. The horizontal asymptote is now moved a bit upwards. So that was pretty straightforward. All you had to do was transform it. Okay, so these were the questions that we've had to discuss today. So we did A, and AI, paper one, paper two, both SL and HL, one question each. So I hope everybody had something to take from the session. So I can now take your questions if you have any.
Yes, Tanushi, there was a one question that if you can give some tips for the upcoming exams.
All right, so I think for the upcoming exam, the best way is to do timed practices and make sure that whatever solution you write, you're checking it against the mark schemes and you're writing all of the things that you're supposed to, and you're not missing out on anything. You're always rounding to three significant figures. Um, don't forget um, that if you do not round answers at the end, you will lose marks because that's not the exact answer that they're expecting. Also, remember to not round in the middle of the steps. So students have this habit of rounding things in the middle of the math. Like they found out an angle using cosine rule or sine rule or something. They rounded it and then they used it to find something else. So now that answer gets deviated from what it actually should be. So rounding is only and only for the final answer, never for the steps in between. Remember that always. Make sure you're leveraging your GDC for paper 2 in AA, paper 3 in AA, and for all the papers in AI, of course. There are things that you can do with your GDC which make your paper much, much easier than doing it manually. So definitely leverage that. Um, as I said, timed practice of past papers, any practice that you can find from anywhere, any resources, do as much practice as you can for math. I think that's the key.